Okay, we have a pump is used to lift 100 kg of water from a well 60 meter deep in 20 seconds. If the force of gravity on 1 kg is 10 Newton, fine. So pretty easy. So we have to go for given. Given we are writing the weight, the mass. The mass is given as 100 kg. Okay, height is given to be 60 meter deep. Time is given to be 20 seconds. And of course, we have gravity. Like I said, we have G is given as 10 Newton per kg. Sorted. So let's go for the solution. So let's go for the first part. Okay, so we understand that work done. So work done can be taken as F into D. Now the F here is M into G, whereas the D here is the height or the depth, you can say. Okay, so we have 100 into 10 into 60. So that would be 60,000 joule. So the work done is 60,000 joule. Okay, so that is easy. So let's go to the next part. Now the potential energy stored in the water. So if you can find out, so basically what we did here is work is mgh. So the potential energy is stored. Yeah, you can say the stored potential energy is mgh, which we just found out to be again 60,000 joule. Let's go to the next part where we are finding the power. The power is easier. So by the formula, we have power is equal to work done upon time. So we have work done is 60,000, time is 20 seconds. So let's cancel this. We have 3,000 watt. Now, since this is in joule and this is in second, everything in SI, so therefore the unit will be watt. And that's it. Thank you.